Hi all, thank you for your interest in this work. My name is Yogesh Kumar Meena and today I will be talking about the concept of PV tiles, which is photovoltaic and digital material for useful, beautiful and sustainable interactive surfaces. This has been co-created via cross-disciplinary work by material science and SCI science and was done at Swansea University. In this work, we are presenting PV tiles concept by fabricating PV cells and creating the PV tiles with aesthetic pattern to match the surroundings, transparent windows to integrate a reflective display, serve as both energy harvester and gesture sensor. As we are aware, Internet of Things devices are growing rapidly. Some sources claim that as many as 127 new devices are getting connected every second to the internet. However, IoT connected sensors, actuators, and display come at high cost in terms of both energy demands and the clutter they bring to the physical world. But what if such devices were made of materials that enable them to sell power their interactive features? And what if those materials were directly used to build aesthetically pleasing environments and objects that met practical physical need as well as digital ones? These were two core questions of our research. Our work is inspired by both William Morris and Mark Weiser. We are exploring home tiling materials that can deliver element of Weiser's vision and satisfy the extended Morris golden rule. This is close view of a China tile design by William Morris. Morris hand painted decorations feature simple scenes and patterns, often flowers, reduced to stylish elements, and are often painted with distinctive, vibrant blue on a white background. On the left, this is 4 by 4 array of PV cells with transparent windows fabricated in our lab. To the right, this is the PV tile with a reflective display and PV surface design matched to its surroundings. These are some example of non-interactive tiles that created in our lab that are patterned and colored and a commercially available flexible PV strip. As explained in previous slides, with such interactive and non-interactive forms of PV material, aligned with digital interactive elements, we envisage a novel class of IoT devices that can be deployed in ways not at possible with most existing smart home technologies. First, as with conventional tile that decorate surfaces around the home, they can be more fully embedded in the environment rather than adding additional clutter to the space as separate objects. Second, as the PV tile material and the digital elements are closely coupled, changes in the light falling on the tile can be used to directly drive digital interaction. Third, as they are intended to be cell powered, they can be built into surfaces and objects without concern for wired infrastructure or need to open or detach them to replace a depleted battery. We present PV tile with the concept explored in the user summit and challenges explored in the expert summit. In the user summit, we carried out two sessions. Session one was scenario co-design round. In this session, we asked each team to engage with one of the four zones that we had set up in the large open lab during the each 30-minute dialogue lab round. Three zones represent different home life settings. One was household sitting room, another a dining room, a third, a kitchen, the fourth contained other objects commonly found in a house. In each zone, we provide a variety of objects and images to provoke use case thinking. We made 8 low fidelity prototypes given the participant discussions designs to capture the range of surfaces and interaction. Envisage across the 4 dialogue lab zones. Here, I will present you some example of low fidelity prototype. For example, in the sitting room zone, an interactive coffee table made up of a series of PV tiles. Tiles show notification, messages from a user's phone. When occluded, the messages are moved still visible tiles. Another example, in the sitting room, flexible PV tiles built into a fabric armchairs. User can show gesture or touch to select to control either the music volume, light intensity via the gestures. For example, in everyday household object zone, a semi-rigid PV tile built into a book cover showing the page last read on the ebook version of the physical books plus review and comments from the other reader and so on. In the session 2 of user summit was designed to elicit potential shadow gestures that could be directly detected by the PV tiles built into surfaces or objects without other external instrumentations. We provide each group with 2 position adjustable LED lamp for making shadows on a wall or table. Some example gestures such as turn it off, ring someone, smart. In session 2, during the shadow competition task, 128 gestures were created by the teams. The purpose intended fell into one of 3 main categories. 28% to control aspect of media playback, for example, turn on, off, increase, decrease volume, etc. 31% to control physical element in the environment, example, unlock a door elsewhere in the house, turn on lights, and 41% to initiate some form of communication. For example, start a call or send a message. We noted wide range of alternative gestures for similar action between the groups. This second summit was carried out a month after Summit 1. The low fidelity prototypes created from Summit 1 were used as drivers for Summit 2. We brainstormed with experts to comments on the extended the ideas from their interaction designs, applications, and technical perspectives. Following the co-design workshops, we built a working PV tile prototype to explore the viability of cell-powered PV-based interaction. The workshop identified a range of rigid, semi-flexible, fully flexible deployments along with the diverse set of sensors, actuators, and displays. For this first prototype, we focus on rigid form factors for 2 of the scenarios identified in the workshops. We use PV tile prototype to implement design idea created in workshop. We created 2 PV tile demonstrators that are kitchen wall and tabletop. In the kitchen wall demonstrator, user can select calendar, weather, and recipe apps by hovering above the icons and can scroll or clear the digital content by swapping over the content. In the tabletop demonstrator, user receive visual notification, for example, Twitter, WhatsApp, email. When an object occludes part of the tile, the display is reconfigured so that the notifications are still visible. This work presents a new class of sustainable IoT technologies. We introduce and build the first prototype of cell power interfaces during this work. We hope you found this presentations, information and intriguing. For more information, please go through our research paper. The link for the paper is available in the description below. Also, if you would like to explore the toolkit of this research, include the code script, process documentations, and other information related to this research, please visit the link given in the paper. Thank you for listening to this video. Thank you.